Open 15 underscore final. As you can see, the structure consists of two disconnected sections. The top section was created so that there is space for the I-beam, which will be created later. To connect these two sections, we will make use of an RBE2 element. For more on this element, view Supplementary 9. First, we need to create the nodes at the point where we want to connect the RBE elements. Open the Nodes Elements tab and click on Node in the Create group. Make sure the method is multiple locations and that Auto Apply is checked. Select the 8 nodes as shown. When done, close the form. Open the Assemble tab and click on RBE2 in the Rigid Connectors group. For independent node creation method, select Specify Node. For independent node, select the top node, and for the dependent node, select the one directly beneath it. Click on Apply. Do the same for the other 3 sets of nodes. Click Apply after each node. Close the form when finished. Open the Meshing tab and select Curve. For Curve to mesh, make sure that only the curve filter is selected. Select all the curves, make the element size 100 and click on OK. Open the Nodes Element tab and click on Equivalence. Click on Preview to show all the coincident nodes. Click on OK to merge these nodes. Click on Materials and Properties and create an isotropic material with a Young's modulus of 207 gigapascals and Poisson's ratio of 0.3. Click on Beam Section and create a tube with a radius of 16 and a thickness of 3. Click on OK when finished. Click on Beam Section and create an I-beam with the dimensions shown in the image. Click on OK when done. Click on Beam. Select Library, change the view to Front. For entities, select all the elements at the bottom section of the structure. For materials, select Steel, and for section name, select Beam Section 1. Click on Apply Elemental Data and make the orientation vector 1, 2, 3. This is so that the orientation vector does not lie along any of the longitudinal axes of the beams. Click on Apply. Select Library. For entities, select all the elements at the top part of the structure. Do not select any of the RBE elements. Choose Steel for the material and Beam Section 2 for the section name. Click on Apply Elemental Data and make the orientation vector 0, 0, 1. This is so that the orientation vector is aligned with the Y-element axis of the beam. Click on OK. Click on Elemental Detail Drawing and select 3D Beam Section. Change the view to FE shaded with edges. Turn off Element Detail Drawing. Create a fixed constraint at the 4 bottom corners of the structure. Change the view to top and create a total load of 6,000 newtons in the negative z direction on the elements shown. Click on Detailed Rendering to make sure that the force is in the correct direction. Turn it off again. Create a point load of 5000 newtons at the node shown in the positive Y direction. Create a new Nastran job. Right-click on Output Request and create a grid point force balance output request in the Nodal Output menu. Right-click on New Job and select Run. Wait for the analysis to run or monitor the FO6 file to determine when it has completed. Attach your results. Click on Deformation, select Translational and click on Update. Click on the Deformation tab and make sure that the deformation scaling is set to 10% relative. Note that the beam with the total load has deformed as expected. Change the view to top. We can see that the structure twists slightly due to the point load. Open the Plot Data tab and click on Target Entities. Select Elements in the drop-down menu. Click on Hide. Select the element shown. Click on Update. Note that this displacement is much smaller than the displacement caused by the total load. This is due to the fact that the structure is much stiffer at the point where the point load is applied. Click on Hide. Click on Free Body in the Results group. There are a few options on the right side of the window under Load Selection. Click on Auto and click on Free Body Diagram. You can now see all the loads at the specific connections. The arrows with 2 pointers indicate moments. Click on a few other options in the Load Selection group. You can only use the free body option if you create a grid point force balance output request. Click on Auto again and click on Hide. Change the result type to Fringe. Select Bar Stresses Actual. Click on Von Mises and click on Update. Click on Bar Stresses Bending and click on Update. To view the total maximum stress caused by both bending and axial tension or compression, click on Bar Stresses Maximum Combined. Click on Hide and close the form. This tutorial was proudly brought to you by Estec.